What's going on, everybody? We're going to continue our discussion in this video on arithmetic series. We started that in the last video. In the last video, you learned how to find the sum of the first n terms in an arithmetic series using one of two formulas. And in this video, we're going to kind of look at it from the opposite perspective where you already know the sum. You're going to use the sum of an arithmetic series to find other information about the series or its related sequence. Meaning, I might know the sum of the first 12 terms is 285, and I want to find out what the first term is, or I want to find out what the common difference is, or the 17th term, any number of things. That's what we're going to do. We got three problems that we're going to be doing that with, just each ways of applying these two formulas that we talked about in our previous video. All right, well, let's get started with this one then. It says that the first term of an arithmetic series is 10.2, and the sum of the first 12 terms is 201.6. And it wants you to find the common difference, D. Okay, well, I wrote these two formulas down here because we're going to have to choose which of these two formulas is going to be most relevant for this situation. And in order to help us do that, I do want to write down the information that's given, which is, just effective problem-solving strategies in the first place anyway. So we're told the first term of the arithmetic series, meaning that we can say u sub 1 is equal to 10.2. Additionally, we know the sum of the first 12 terms, which tells us two things. For this problem, we're going to consider n to be 12, because we're dealing with 12 terms. And then s sub n would be the same as s sub 12. N is supposed to be how many terms you're adding together, so if you know that number of terms, write that number of terms instead of the letter n. The sum of the first 12 terms is 201.6. All right, now here's what we're going to be trying to do. If we're trying to find the first term, we need a formula, hopefully that has u sub 1 as part of the formula. And both of these formulas have u sub 1, don't they? So that in itself doesn't tell me which formula I want to use. But then think about the other information you're given. Over here, do we know the number of terms? Yeah, we know that's 12. Do you know the 12th term? Because that's what n would be here. We don't know what the 12th term in this sequence is, so we might choose not to use this formula right here. Let's see about the other one. We know n again. Good. We know the first term. And we know the term number again. The only thing we don't know is the common difference. And hey, isn't that what we're trying to find anyway? There's another good reason to use this formula. We're trying to find D. This formula has D as part of it. Let's use that formula and substitute this information appropriately into that formula to find out what the common difference is. All right, so let me do that now. The s sub n, we're going to replace that with 201.6. And then we have n divided by 2. Now remember, n is 12 for us, and 12 divided by 2 is 6. Let's just go ahead and write that more simply there. Times twice the first term, so 2 times 10.2. Plus n minus 1 times the common difference. Now again, n is 12, so why don't we just write 11d right there. Great, we set it up where we have an equation to find the common difference, and all that's left for us is to do the algebra. Now, I will make this suggestion. You can distribute the 6 right there, but why don't we just divide both sides by 6? It'll make that a little bit easier. And you'll get 33.6 is equal to, and then now that 6 is gone. Let me clean this up a little bit. 20.4 plus 11d. And then if you go ahead and subtract 20.4 from both sides and then divide by 11, you'll get 1.2 for the common difference. Great. All right, so you have the concept already. We just have to see different types of questions they can ask you in different ways of presenting information, which is why we got these next two examples. Let's try this next. All right, you see this series that we're trying to work with written there. It says write an expression for s of n for that series, and then find the value of n for which the sum of the first n terms, is 270. All right, well, let's go ahead with part A. But before I write anything down, it seems sensible to me to talk about which formula we're going to use later on when we try to find the value of n for which the sum of the n term is 270. And it turns out the second formula, I think, is going to be a winner again, because, simply, we don't know the nth term for the sequence, right? And since we don't know how many terms there are, because that's what we're trying to find, we're not going to be able to figure out what the nth term is. So let's use this formula. And why can we use it when we couldn't use the other one? Well, we do know the sum of all the terms. We're trying to find n, so it's okay to leave the n there. We know the first term. Again, we know n, and we can find the common difference, right? Isn't that just negative 20? So I'm going to use this second formula here, and since I'm going to use that for part B, let's use it for part A as well. The sum of the first n terms for this series would be n divided by 2 times 220, twice the first term is 220, plus n minus 1 times negative 20. Because that's the common difference, right? And that is our answer for part A. We basically were writing a formula that you can use to calculate the sum of the first n terms. Now what we're going to do in part B is we're going to say, all right, let's suppose that this sum is equal to 270. What would be the term number, the number of terms that we'd be adding together in order to make that sum reality? So we plug in 270 there, and everything else is going to kind of stay the same. We've got the n over 2 times 220. Now I'm going to do a little bit of simplifying here. Let's go ahead and distribute this negative 20. That will give me a negative 20n. And then negative 20 times negative 1 plus 20. And just solve this equation for n. We do have n in a couple of different places, don't we? We've got n right here. We've got n right there as well. All right. One thing I'm going to do here that's going to make this look a little neater, doesn't serve any other purpose, is I'm going to go ahead and multiply both sides by 2 and get rid of that denominator. Now, multiplying the left side by 2 is going to give me 540. If I multiply the right side by 2, that 2 is going to cancel, but I still have this n, don't I? And I need to distribute that n to what's inside of here. Well, I'm going to have 220 plus 220, or 240 times n, so 240n. And then I'll have negative 20n times n, and that's negative 20n squared. Notice we've got a quadratic equation. And to make this a little bit easier to solve, since all of these terms are divisible by negative 20, let's go ahead and divide by negative 20. That will give me negative 27 equals negative 12n plus n squared. And then we'll set that equal to 0 and solve. 0 equals n squared minus 12n plus 27. And this is a factorable expression, which is kind of nice. We were expecting to get integer answers, so it makes sense that this is factorable. N minus 3 times n minus 9 would be the factored form, which means we're going to get two answers here, which is really interesting, actually. N equals 3 and n equals 9. And the reason I say it's really interesting is, remember, there were two terms, we were trying to find how many terms in this series you would have to add up to get 260. So what we're basically saying with two different values of n is that if you add up the first 3 terms, you get the same thing as if you add up the first 9 terms. I want to show you that that actually worked. I hope you were thinking earlier when we found out, I hope you thought whenever n equals 3 that, hey, we already had the first 3 terms, didn't we? And indeed we did, and indeed they do add up to 270, right? 110 plus 90 plus 70 is 270, so we can kind of confirm that way. And I want you to think about what the next 6 terms would be, just so you understand why we got two different answers here. I'm going to write those out for you. Now, if I kept decreasing each term by 20, you see how I get this. I'd go from 70 to 50, 30, 10, negative 30, negative 50. And do you notice how those next 6 terms cancel each other out? 50 minus 50 is 0, 30 minus 30 is 0, 10 minus 10 is 0. So indeed, if you add up the first 9 terms, it gives you the same thing as if you added just the first 3 terms for this particular sequence, just because the next 6 terms canceled one another out. All right, one more problem to do. And I'm just presenting the information to you differently, asking you to do a similar thing. In an arithmetic sequence, the 5th term is twice the first term, and the sum of the first 16 terms is 1288. Find the first term and the common difference. What do we want to do with this? Let's record the information that we have and then try to make a decision as far as which formula we're going to use and what we'll do with those formulas. This first little part of the information here tells me the 5th term is twice the first term. So I'll label that means u sub 5 equals 2 times u sub 1. All right, then we're told the sum of the first 16 terms. So for us in this problem, n is going to be equal to 16, and s sub 16 equals 1288. All right, now just as with the other problems, it turns out that we're going to use this second formula. Doesn't that get used the most often, it seems? And the reason we're going to use that is we don't know what the nth term is. We don't know what the 12th term in this series is. And we don't have any information really that we could use to find that out easily anyway. It could be done a little bit later on. All right, so what we can do, though, since we're trying to find the common difference and we're trying to find the first term, is let's use the formula that relates the common difference and the first term together. And let's just substitute everything that we possibly can into that formula. Now, there's nothing we can do with this information yet as far as this formula goes, but we can replace s sub n with 1288. And since we were finding the sum of the first 16 terms, we can replace this n with 16, and 16 divided by 2 is 8. We don't know the first term, so let's leave that as 2u sub 1. We again do know the value of n is 16, so n minus 1 is 15. And then we don't know the common difference, so let's leave that way. Now this looks like it doesn't do us much good because, well, we have one equation and we got 2 unknowns in that equation. Sometimes 2 unknowns are unavoidable. This is one of those cases. And whenever you have 2 unknowns, you need to know the 2 equations that relate those unknowns. So we're going to need to figure out another equation that relates u sub 1 with d. Now this is where the other piece of information that we haven't used is going to come into play. We know that u sub 5 equals twice u sub 1. How does that help? Watch. Just knowing what you know about arithmetic sequences, you know that the 5th term in an arithmetic sequence is equal to the first term plus 4 common differences, don't you? So if the 5th term then is twice the first term, I can take that equation and I can make it 2 times the first term equals the first term plus 4d. And then if I subtract u sub 1 from both sides, then 2u sub 1 minus u sub 1 is u sub 1. We get u sub 1 is equal to 4 common differences. I know what the common difference is in relation to u sub 1. Actually, kind of the other way around. How will I use that? Well, I can now substitute 4d in place of u sub 1 into the formula that we were using earlier. I'm going to make that substitution. I'm going to go ahead and do one other thing on this step. I'm going to go ahead and divide both sides by 8. So this becomes a 161, and this is canceled out. And then we're going to have 2 times 4d plus 15d so that's 8d or 23d equals 161. And that's going to give you d is equal to 7. Great. We got one of our answers here. We wanted the common difference. The other thing we wanted was the value of the first term. And the first term is just 4 common differences. So 4 times 7 is 28. There's your first term. All right, these problems take a lot of practice, but not overly difficult once you learn how to manipulate the formulas that are given to you. And you see how this one is used a whole lot. Good luck with your homework problems with this. I'll see you in class, guys. Thanks for watching.